Good afternoon to everyone. I welcome you once again after this break. Tamil.
Okay, ma'am.
Okay, continue.
Okay. Welcome back again. So today we are having a hands-on session with respect to essentials of deep learning, that too with a different framework, that is Pytorch. Okay. So I will present the screen, check for it visibility. If any issues, kindly interrupt me. If you give in the chat box, it is not visible during presentation. Kindly go ahead with that. Hope my screen is visible for you. So hope you know that I think people are clear with Colab laboratory. Am I right? Kindly acknowledge me in these aspects. Are you clear in how to work with Colab? Kindly give your response in the chat. Is Colab familiar for you?
Yes, already they had some
Okay.
lab.
Okay, ma'am. Okay. So then it is not an issue for you. Is the font size okay for you?
Yeah, yes.
Okay. So similar to TensorFlow, Pytorch is an environment which provide you for the calculating the gradient. Hope you know what is gradient, right? We have seen in the morning session, right? Gradient is very important in the update of it. We have seen these rules, right? W of t plus 1 equal to W of t minus eta into del of W. The del is nothing but a gradient. Here del is nothing but a partial derivative. So these partial derivative aspect is a computational intensive. That's why deep learning is mainly said as computational intensive job. So to overcome this, it is difficult for the scratch coders to get the weight updates for each and every epochs on the manual basis, so that this PyTorch is nothing but a framework which will give you the updated gradient. That's it. It will not provide you the result whatever you want. It will provide you only the gradient working alone. Please have a look on it. PyTorch and TensorFlow is nothing but a framework for which your gradient descent algorithm is working on it. That's it. So it is nothing but a framework. So PyTorch is originally originated from the Facebook. So it is earlier it is proprietary of Facebook, then it is open sourced. Now it is under open license. So PyTorch has two important characteristics. I can say that it is equivalent to NumPy. For instance, hope you have learned NumPy and other aspects in the previous sessions. So PyTorch is equivalent to NumPy. So hope you know what's the use of NumPy. Hope you know. Do you know why we have moved from the collections, Python collections, to NumPy and other thing? So the main aspect of the moving from collections, that is list, tuples, dictionary, to NumPy is that in order to deal with the high dimensional data, that's why it is called as n-dimensional array, ND array. So NumPy is nothing but an ND array. So PyTorch will have the equal computation or equal concept with related to ND array. Next thing is the salient feature. I can say that this is the core feature of the PyTorch. One is automatic differentiation. So autodiff is one of the, we are going to see that how the in math we will do these aspects as a problem, right? In our school days, the same thing will be given by the PyTorch, but this is absent in TensorFlow. You can have a track on it, you can have a hook on it. Based on that hook, you can get the differentiation point. So autodiff is an important, I can say that the salient feature of PyTorch, whereas TensorFlow will do it, but you cannot hook it at the particular point. That is what the thing. TensorFlow is also doing the gradient and other thing. This is one of the salient features in that you can visualize what is the thing going inside the deep neural network. So these are the outlines of today's thing. So this is what the introduction. Then we are going to see tensors and how these tensors. I can say that tensors are equivalent to NumPy arrays. Very simple. Then how to initialize slicing and reshaping for a while. Then NumPy and PyTorch, how to interface. You can use both NumPy and Pytorch for your working thing. How to enable the GPU support in Pytorch. Then we will compare the speed of it. Then AutoDiff. Then we will go for a AutoGrad. How AutoGrad works here. Okay, these are so I have divided this session into two parts. First session is meant for introduction to PyTorch and working on it with its capabilities. Second session, we will move on to some of the deep learning. That too, I can go with the feed forward network. Okay. Hope your things are clear. Fine here. We will move on to this. First one is, so first is you have to, as usual, Torch is the library, Python library. Torch is the library in Python which supports PyTorch. So if you are using Colab, there is no need to install Torch and NumPy. It is by default, it is enabled because this is a cloud environment, right? All the cloud, all the installations that are needed are done as a Docker file. So there is no need to install Torch and other aspect. If you are going with your local machine, you have to install Torch and other thing with using the command called pip. Okay, if you are going with these things, that is not at all essential because Colab is nothing but a cloud environment, virtual cloud environment that is set for us. So it is all the necessary underlying compilers and other the interpreters and the necessary libraries are provided as a Dockers. So as usual, you have a NumPy and you have the alias name as NP, matplotlib. Hope you have done all these things right. So first we will move on to what is tensor. First, tensor is nothing but I have already told that it is an equivalent to NumPy. So in NumPy, in a single dimension, you are saying that it is a vector. If you go with a multi-dimensional, it is, you will say it as a, in two-dimensional, you say it's a matrices. Am I right? So this is nothing but tensor is nothing but generalization of vectors and matrices. That's it, which is equivalent to NumPy. In NumPy, you have a single dimensional array. Always have a look on it. If you are going with the deep learning algorithms or deep learning models, vectors are nothing but single dimensional, whereas two-dimensional are given as matrices. You can have high dimensional too. Then tensor and also each tensor is associated with input, output and weights. So it is very easy to model your deep neural network. So as usual, you know how to create a NumPy. In NumPy, you can say that you can create a NumPy array of ones, NumPy array of zeros and NumPy array of random numbers. Same thing, you will use np.ones, np.zeros, np.random, right? Instead of that, you have to use starch.ones, starch.zeros and other thing. Hope you got the things right. Yes. Instead of NumPy array, I am using Torch. This is the Torch instant I have used. If I give ones, 3 rows, 2 columns, 3 rows and 2 columns, zeros as usual, then random numbers of 3 rows and 2 columns. Hope, wait. So same as that of the NumPy array. Next one, first I will explain the thing, then I will share you the Python notebook. Then you can execute for a while for 10 to 15 minutes. If you have any doubt, you can go ahead with that. Okay. So as of now, I'm going to present the things for you. So next one, if you want to create an empty matrices of dimension 3, 2, if you give empty, the memory will be allocated. Whatever the thing that are present earlier in the memory will be displayed. If you want to go with, you want your memory to be 0, you have to go for 0. So this is the 0 tensor. See here 0. If you give empty, it will not give you empty because it will give you dangling pointer. Am I right? Hope you have got these things like dangling pointer will be an important issue in memory management. So in order to avoid that, it will allocate the memory, but in that memory, whatever the already present value is there, it will retain that. Next one, 0 likes. See here, zeros like is nothing but we are going to create a tensor. So always make a note of it. Tensor is nothing but vector and matrices. Now I'm saying instead of saying arrays and other thing, now I'm going to give a tensor. So torch dot zeros dot underscore like means like that of whatever the argument I have given. For instance, if I have given x, it will take the shape of the x as it, and it will produce a zero tensor. That is what the zeros like will have. Similarly, you have n number of functions on it, you hand back on it. So this is the thing. So next one, linspace. Hope you know that this in the matplotlib you have gone with it. So x is equal to torch that linspace of 0, 1, step is equal to 5. So inclusive of 0, 1, 1, it will give you the 5 values which are equally distanced. So see here 0, 0 0.25, 5, 7.75 and 1. So linspace, this is what the linspace. Hope you got these in the numpy 2. So manually also, by default also, you can give the values like this, but you have to have a look on it. If it is a 2-dimensional array, you have to enclose it within 2 square bracket. That's it. This is same whatever you have seen in the numpy. Only thing, instead of numpy, you are going to use torch. So variation will be there in place of auto grade and other things, auto differentiation and auto grade. Slicing as usual. Hope you have the function called size. Size will return you the number of rows and columns. Then if you have given colon, print x of colon comma 1 means colon. If you give colon, it will take all the rows, but only the first column. Okay. So if you take all the rows, sorry, this is 0th column, this is first column. So it will return 2, 4, 6. So if print 0th row, but all columns. So 0th row is this, all column is 1, 2. So it will return output as tensor, not an numpy array. So there is a need for them to convert it into numpy array or as a scalar value. So whenever you use a torch, it will return the value as tensor. In order to have only the scalar value, you have to give the thing called item. For instance, see here y equal to x of 1, 1. So this is 0th row, this is first row. In first row, first column is 4. If you give print of y, this will return it as a tensor. So this will return it as a tensor. If you want it as a scalar value, you have to use a function called item. Okay, clear with this? Y dot item. So now it is a scalar value. Okay. Then one reshaping. For reshaping, it is view. In NP, in NumPy, you have a function called reshape. Now here it is a view. For instance, this is a x tensor. This is a tensor x. In that x dot, its dimension is 3, 2. 3 rows, 2 columns. I want to map it to 2 rows and 3 columns. You have to give it as y equal to x dot view of 2, 3. So these are dimensions. Okay. Then next one, in the view also kindly experiment this. X dot view of 6 rows, 6 rows, minus 1 means only 1 column. Okay, 6 rows, 1 column. If you give minus 1, 6, you have 6 column, everything in 1 row. Hope you got the things, am I right? Instead of reshape, you can go with the view. So these things are simple. So the next one is tensor operations, which is equivalent to addition, subtraction, multiplications, whatever you can. You can use either the operator or you can go with the functions. Defined functions are also there. First, we are going with the operator. This is x tensor and this is y tensor, which are all ones of dimension 3 cross 2. Now z is equal to x plus 2 is nothing but a z tensor will have all the values 2 of dimension 3 cross 2. Hope you got this right. Then z is equal to x minus y. All are 1, so you will get 0 tensor. Then x star y, you will get 1, 1's tensor. Hope you got these things right. A very simple one. Next one, you instead of going with the operator, you can also use the method add. So z equal to y dot. This is the first operand. Second operand should be given as a function to the argument. You will get this. So if you give print, so my y is 1, 1, 1. And then my z is added values. So this is the 2, 2, 2. So this is y dot add. Have a look on it, another function called y dot add underscore. This is called addition in place. In this case, what will happen? Whatever the first argument itself also changes. Z equal to y dot add underscore of x means it will take x. For instance, if you want, go and print x also. See here. Wait, I want to know what is y before. Wait for a while, I will print here. I'm going to print x. Then I'm going to print y before performing this operation so that you will get an idea about it. So initially, I think it has changed, I think so. Okay, have a look on it. So initially, my x is 1, 2, 3, 4, 5, 6. My y is 1, 2, 3, 4, 5, 6. Okay. When I give z equal to y dot add of x, so z will add these two things. So 2, 4, 6, 8, 10. Okay. Now, if you give add underscore, this is called as addition in place or in place addition. This y is also updated. So now the y value, see here. So this is x, this is y, this is z. Now the y value is a result of this. Okay, now the y value is a result of this also. If you print x, see to the x remains the same. Hope you got the things right. Whatever the operand you are using as a first operator, this will also have a change on it, whereas the second operand will not have the changes. This is called in place addition or addition in place. So you should be very cautious in doing that. Okay. So these are the things with respect to basic operations with respect to tensor. Next, we are going to have a comparative thing on NumPy and Pytorch. Oh, that is tensor. So for example, if I'm going to print x, now my x is changed. That is 1, 2, 3, 4, 5, 6. My x is a tensor. See here, my x underscore np equal to, right, x is a, see here, this is my x. The output for this is, see here, this is the thing. This is the output for x. Then now I have converted my tensor to numpy using a function called numpy, tensor dot numpy. This will convert your tensor to numpy because you cannot use the tensor as such on some of the deep learning methods. In that, you have to convert that into numpy array. So in order to do that, you have to convert this first. In order to convert that, the function for that is tensor dot numpy. So now if you print the type of x, here the type of x is as usual, this is tensor class. If you go with x underscore np, its type is a n-dimensional array. That is what the numpy. Okay. So now if you print the thing, this is what the numpy array. See here, there is no tensor like these things in the numpy array. Hope you got these things right. So very simple one. So next one, how to convert the numpy to tensor. Okay, next we are going to see. So in that, we are creating a random number, 5 random numbers from 0 to 1. So a is equal to np.random.random n or random. If you want int, you can go with that random n. It is a meaning that you are using, going to generate 5 random numbers between 0 to 1. It can take it automatically randomly. If you print this, this is what the thing. If you want to know what is the type of A is nothing but numpy array, that is why nd array. Next, I have converted this A into a tensor with the help of a function called from underscore torch dot from underscore numpy. From underscore numpy. So you have to give a function called torch dot from underscore numpy of numpy array. If you give that, then it will be converted to tensor. So this is vice versa. So if you give the type of it, it is nothing but a tensor class. If you print that also, you will know that this is a tensor value. Okay. So the next one, so np.add, you have, wait, we will show you what is a here. Okay, wait for a while. This is different way of using. I think I have not executed anything. Wait. So my A is, this is what my A, okay. This is, okay, if I want, you can print this. This is my A from the previous thing. This is my A. Now np.add a comma 1 comma out is equal to a. So if you give this is numpy. You can visualize this. If you get the tensor in the front of it, you can say that this is a tensor. So np.add a comma, the other way of adding. This is simple thing. Other way of adding, the output should be stored again in the a. That is numpy array itself. This is other way of adding. Simple operation. We have seen the simple operations like how to add the things with the out will give you in which array we have to store the output. Okay. So the next we have seen how to convert the numpy to tensor and tensor to numpy. Then we have seen some of the class and we have seen addition in place. Similarly, you have subtraction in place and other things also have exploration on this. Then we have seen how to reshape it with the help of a function called view. Then slicing as usual, whatever you have done in numpy array, same thing. Then default arrays that can be created with the touch. As of now, we have seen the basic things. Now we are moving to how this Pytorch, both TensorFlow and Pytorch will go with the what I can say GPU thing, because deep learning models are computational intensive. So in order to avoid that, what we have to do, we have to go, our CPU is not capable of going with that. So we are going for GPU. So in order to enable GPU, hope you know that as of now, we will check on this and in need, we will go on that. So percentage time is a magic function. This is called as magic function in Python. If you go with that, this will give you the CPU clock time. Okay, CPU time and wall clock times are printed. That is how long it will take to run in the CPU. Okay, percentage time. If your GPU is enabled, GPU time is also given. So this is called magic function. For instance, you have to enclose all your code within this, then it will give you the execution time for this. If you run this, see here, the CPU time is 136 and the system time, this is very simple. System time is nothing but CPU time is with respect to user, with respect to system. Okay. With respect to user, it is 136 including request response. System time, only the time at which this process is in CPU. That's it. System will look on to like this one. But we will take queuing time, response, request and other times. That's why it is 136. So then this is the total time. Wall time is nothing but it will give you what is the overview of the time that is needed with respect to CPU and the user aspect. Okay, so if you go with and search with the wall time, you will have a look on it. So this may vary, sometime also have a look on it. See here, it will varies. So depends upon the CPU clock cycle and CPU idle time. This may also varies. I cannot say that this is constant for every moment. This will varies because if background process are running in the CPU, it request response time also varies. Based on that, you will have the different timing. So this is for I in range, I have given something matrix multiplication. This is with respect to an numpy array. Now I have used the same thing, but instead of numpy array, I have used the torch. See here. So if you see here, torch will have the 3 times the reduction of the time. See here, in the user time also, it will take only the less amount of time. In system time, it is saying that it is 0. It is a meaning that if you run for 1 or 2 times, see here. It is saying a 0 nanoseconds or microseconds. It is very minimal in system. That's why mostly Torch will have its own computational capabilities. It will not depend on CPU. Mostly it will process with its own library functions. It will not give the, for instance, if you are using addition for, if you are performing addition, you have to use the CPU, means you have to use ALU. Hope you have read these in the architecture, right? You have to use register, you have to use ALU and other things, right? If you are going to use that, use those CPU entities, there will be a system time. If you are not going to use that CPU entities, your time will be reduced. So internally it will do manipulate on it and it will work on it. You may ask how it will do. You will work, you will see this. I will show you within a minute how these things are done with respect to differentiation itself. This is simply a matrix multiplication. Even the differentiations are done very fine with the help of Pytorch. So same thing for larger values. For larger values, given that it has taken 1 minute 26 seconds, and for the other thing also. So go ahead and check on this. These are basic things. So with this, I can say that even though if you have not enabled GPU support, it will provide you the, because I have not given any code for GPU entity. Please have a look on it. As of now, I'm using the CPU only. In that CPU execution itself, if you take Torch is overperforming, or I can say that NumPy array is underperforming compared to Torch. Okay, because of its Torch has its own built-in capabilities. So first thing I want to show here is that in order to enable, hope you have learned these things. For those who have not an idea on this, I want to give a how to enable GPU support in the Colab laboratory. In order to go with that, go to the edit notebook settings. In that you have a hardware accelerator. You have three options. This is none, GPU and TPU. As of now, we are going with the GPU. Give that and save it. Okay. So once you have done this, what you have to do, you have to check whether how many CUDA devices. CUDA is nothing but Compute Unified Device Architecture. So this cloud environment, Colab cloud environment is providing you Compute Unified Device Architecture, which is nothing but you can run either with CPU or with GPU. It is not that you have to run only with, if GPU is enabled, it is not that you have to run only with the GPU. You can go with CPU or GPU at your own convenience. Because in deep learning model, if you go with a gradient algorithm, that only take maximum time and that is a computation intensive. For those things, I can push the data to GPU. For remaining thing, for data pre-processing and other thing, for according to me, for data pre-processing and other thing, I can go with the CPU. It is up to us. So this is a Compute Unified Device Architecture. This is what the CUDA. So this CUDA is present in the Torch library, and this will tell you how many devices are present here. In order to go with that, have a click on it. It will show you how many device count are there. Even if your laptop support GPU also, you can access on it, but it has different thing. But the coding is, this is not code. If your laptops or your machine or your local machine support GPU, you can work on it. But the code is, this is not the code. Probably, if possible, tomorrow I will show you a demo on it. Okay. So as of now, I have one CUDA. If I want to know if it is nothing but it will return an array. As of now, cloud has provided me only one CUDA. Okay, GPU. That is, GPU is called as CUDA. Okay, so this is a free support by the Colab, right? That's why only one CUDA. If you go with Amazon AWS web servers and other cloud aspect, you can request for more than one GPUs. Okay, that is payable, right? So this freeware will support one GPU. If you want to know, so that is an array. So in order to access that, this is mostly, it is not an array, it is a tuple. So you cannot change those aspects. This is provided by the virtual machine. This virtual machine will give you provide you the GPU support. So that's why first device, I want to know the first device. It will return the instant of its device. So that is the device object. If you want to get the name of it, Tesla. Mostly this is in the server, I can say that in the Colab server architecture, that is cloud architecture, The GPU is nothing but Tesla. For if you take in your laptop, it is NVIDIA, right? Mostly your GPU is NVIDIA, right? Similarly, in your cloud environment, that is in Google Cloud, where the Colab is hosted, in that the GPU's name is Tesla K8. It varies, okay? But mostly in Colab, it is Tesla. But in your machine, it varies. If you are going with the high end, mostly it is NVIDIA. Okay, clear with this? So next one, so first you have to, I'm creating an instance of it instead of using all the time. So if you have CUDA 1, 2, 3, 4, 5, and 6, you can use everything. As of now, I'm going to use only one CUDA whose index is 0. So now I'm creating an instance of it. I can say that this is a reference name. So CUDA 0 equal to torch.device of CUDA colon the index of it. As of now, I have only one, that's why 0. If you want, you can go with the second one if it is provided. So see here, so A equal to torch.1, as usual, only thing you have to add the thing called device. Instead of CPU, if you have not given the anything, it will default run in the CPU. If you have given device is equal to CUDA 0, this CUDA 0 is referring to the first instant CUDA that is created on the cloud. So it will be moved on to the cloud and it will be run. So it is faster, it has a faster capability. Instead of CPU, even though whatever you are running, all the things are running in background in the cloud only. So instead of CPU in the cloud, it is running in the GPU. That's it. Okay. So when you run this, you will identify these. Wait for a while. It is taking time because I have to connect with the cloud. Wait. Okay. See here, it is connected with the compute background and GPU. Okay, so you can identify this in the output itself. It is showing that it is CUDA 0. And now you can say that it is taking time. Why you are using rather than that CPU? It is the first instant I am running, right? There will be a request and response delay, right? That's why it is. Okay, then you can run the A. See here, instant result will be there. Okay, now we will compare the time, how it is working. I will go with the random numbers of large size. First, as of now, I'm going with high dimensions and that too with the random numbers and the range of 10,000 to 10,000. It has a CPU. You can work on it. I will give you the thing. In the CPU alone, I will have it. This is the generalized thing. Then this is what the CPU based. Okay, this is CPU based. Next, if you go with the touch based, only thing you have to give the device equal to CUDA. Okay, it will take minimal time compared to this. See here, this is NumPy array. Only if you go with the larger dimension only you can refer to the changes. If you give 1 and 2, this will not be reflected. I'm sure of it. At least it will take a minute. So meanwhile, I will explain you. This is with respect to, that is with respect to NP and NumPy. This is with respect to Torch. This is with respect to Torch with GPU. So these are the three things. Have you got it? So with the help of magic command percentage time, you can have an access on it. Similarly, this is addition. Here I have gone with the matrix multiplication. This is complex, right? Same thing with respect to torch with CUDA. You have done this. Okay, these are the basic things we have seen. It will take a minute. Meanwhile, I will share you my thing. If you want, you can work on it. If you want, you can work on it. So time now is 2:35. Take 10 minutes, have a look on it. Then we will move on to autograd. This is very important. Autograd and auto differentiation is very important thing. We will have a look on it. These things. Go ahead and work on it on this because it take time. At least it will take a minute because I have done these things in the CPU. See here, it has taken 1 minute 22 seconds with NP, NumPy array. Now I have done with this a torch. It will be a little bit faster. So it has taken 19 seconds. So next I'm going to run it in the CUDA device. See here, it has taken only 6.81 milliseconds. Hope you have got the thing out of it, right? Is clear in this? Same thing, matrix multiplication. So this will take more time. Okay, so have a look on it. I will give you 10 minutes. With that, we will go on to the next part. Any doubts as of now, you can ask me. Any doubts as of now, you can ask me. Next, we will move on to AutoDiff by 245. Any doubts? If you have, kindly take the Python notebook, then work on it. If you find any difficulties or any issues or anything, you can ask me. Or else provide the queries in the chat box, I will answer it. Just try to execute it. Are you able to find the difference or not? Kindly tell me, shall I proceed with the things? Are you executing? I hope you have done these things because it is very simple. So next we will move on to the core concept of Pytorch. That is nothing but automatic differentiation. As I have already said in the morning session, right? The math behind the deep neural networks is differentiation, that too partial derivatives. So those things are being incorporated in the PyTorch. So the options that is available for you is requires underscore grad. If you have given requires underscore grad equal to 2 means it will have a look on it, it will have a hook on it, and it will have a partial derivative on it. First I will give you an example on thing, then you will understand. For instance, x is equal to torch dot ones of 3 comma 2 requires equal to grad. This is an option that will saying that this function is going to be executed with respect to differentiation with respect to some other variable. So if with respect to some other variable, there is a need for partial derivative. Am I right? So next one, I have created a y. Y is dependent on x plus some constant. So now if you differentiate y with respect to x, so there is a differentiations, right? So y equal to x plus 5. When you run this, see here, just since ix in x I am saying that this value is dependent and it is going to be used in some other thing. That's why you see here grad function add backward 0. Hope you got the things right. Next one, z is equal to y star y plus 1. You have created only grade underscore requires underscore grade in only one variable, but the hook is going in depth. This is how you can get the differentiation thing. See here, z is equal to y star plus 1. Now we are printing the z. So it is 36 plus 1, 37. See here, it is also saying that there is a gradient function that is available in backwards. You have to, I mean, you have to move from bottom to up. Then you are saying that torch dot sum, very simple as usual. I have not executed, right? I have executed this. This is 222. This is sum. It will tell which function I have done, whether it is a sum, add, subtract, and other things. It will show you. The important function, see here, the important function is this one. If you give t dot, lastly, this is the last hook that was present for me. If I give d dot backward, it will goes backward. Okay, so it will return the gradient of this. I will give you an example in this. See here, with this function you will you know how to this 12 is derived. See here, t is equal to zi. Am I right? Whereas zi is equal to y square plus 1. Leave these subscript analog. T is equal to z. Am I right? See here, t is equal to z. That is sum of z. That's it. Sum of z. Whereas z is equal to y square plus 1. Whereas y is equal to x plus 5. Okay, where x is equal to 1, just x is equal to 1. Am I right? I have created a ones. Okay, see here, t is equal to summation of zi, where zi is equal to yi square plus 1, where yi equal to xi plus 1, where xi is 1. Okay, xi is 1. Clear with this? Okay. So if you have given with this, first what you are saying, I have hooked from x, now I have derived at z. Now I have give the thing is that I want to find the derivative of t with respect to x, because based on x only y have done, based on y only z has done. My core starting point is x. So partial derivative of t with respect to xi is nothing but dou zi by dou, for t you can give it as zi by dou xi. Now is this zi is dependent on yi. So what will you give? Dou is, this is a chain rule, right? In maths we have studied. These things are the present in the morning session. I have given you only slight thing. All the gradients you have at least a depth of 100 in the chain rule. So dou zi by dou yi into dou yi by if you yi by dou xi. This is what the partial derivative. If you find dou zi by dou yi is 2yi, dou yi with respect to xi is nothing but, go here, partial derivative with respect to x is 1. So 2yi. Okay, this is what the final derivative of this. So at x, what is the value of x for me? For me, the x is 1. Okay, for me, the value of x is 1. The value of y is what? See here, value of the y is 6 here. Okay, so the value of y is 6. If you substitute this, you will get the 12. Hope you're getting the things. I hope so. So that's why when you do this, this is how the gradient will propagate and find the value of it. So if you want to find the output of this, you have to give the origin value, that is x dot grade. You will get the value out of it. This is how the weights are being updated in the deep neural network. We are saying that this way back propagation, hope you got the things right. In back propagation, we have to find the gradient with respect to output unit, with respect to hidden layer, with respect to weight, with respect to bias and other things, right? Those things are done in the Pytorch with the help of this function. Okay, so with these functions only we are working on it. If you give backward, it will go with the backward propagation. This is forward propagation. In forward, you start with x, you find y and you find z, then you have assigned to t. Backward, you have to move backward and find the derivative of it. So if you want to find the result of it, find the starting point and this one, grad. Okay, so this is the input, right? This is the input. This is the input. So that's why it has given. Hope you got the things. I think so. Am I right? So this is one of the salient features of Pytorch too. In TensorFlow, you cannot get the automatic difference. Actually, internally it is doing, but you cannot visualize the things. That's it. Internally, every framework will do this, but you cannot visualize the thing. Now here you can visualize the thing. That's it. So the next one, I have given you the thing. Instead of separate thing, I have given you the simple thing. Here, see here, x is equal to torch. X is ones of 3 cross 2 matrix. I have given you grad underscore requires underscore grad equal to true. Then y is equal to x plus y. Then here r is nothing but 1 by 1 plus e power minus y. That is sigmoid neuron. I have given you these things. I have printed r. Then and find the sum of r, then as usual backward and gradient. Okay, if you want, you can test this. I will give you a 2-minute test this how this 0.25 is arrived or not. Kindly differentiate these things and find whether it is working fine or not. Instead of y square plus 1, I think so. Instead of y square plus 1, I have given 1 by 1 plus e power minus y as a function. That's it. That is the change here. You can test this. You will get the gradient as 0.25. Test for a while. Since I have already shared you, have a test on it, whether it. So this is important feature. Same thing here. You can see the difference here. See here, S is equal to torch dot sum of R, then S dot backwards alone. I have given you another thing. See here, the difference here is R dot backward of A. Okay. Now I am passing this. See here, X is equal to torch, then Y equal to X plus 5. I have R. This is my final thing. Then I want to back propagate to who? I want to back propagate. Okay, back propagate with the value 1. If you want these things, you can give it as r dot backward, or else just back propagate and up to the top. Just you can give it as like this, s dot backward. These are two versions you can use on it. But if you are using that r dot backward, okay, see here r dot backward. Here is also s dot backward. Here s will, if you print s, see here, you will find the difference. Wait for a minute, I will tell you. If you print here, the r is nothing but a hook here. This is, I have printed the r, I have printed the s. Right, I will print you the s. So So here S is a tensor, right? See here, S is a tensor. So next what you have seen, tensor dot backward, it will move as such. Okay, then see here. This is also a tensor. X is also a tensor because this torch is given. So this is tensor. Y and R. We will have a look on what is Y and what is R. Then you will know why there is a need for this. Y is also tensor. Since X is a tensor, this will broadcast, right? This is a two-dimensional array. This will broadcast phi to everything. This is one of the property of the Python, right? So even though this is a scalar, this is broadcasted into these things. Next R is also tensor because I have these things, right? Then there are two ways of it. R dot backward of A with A is nothing but with 1 as your argument. R you can give it as simply the thing R dot backward. It is two ways of going with that. It will not create you any problem in that. Is clear with this auto differentiation? I hope this example will give you a clear insight on how auto differentiation is working in Pytorch. Are you getting the point? Any doubts you can ask me. Kindly post the things in the chat box. I will reply you soon. So the next example, for example, this is my function. This is my true function. Assume that this is my true function. Have a look on it. Random numbers of 20 cross 1. I have told that this requires a gradient. Y equal to 3x minus 2. Then I have created W and B initialized to 1. Okay, 1 tensor. Then y hat is equal to, hope you know that, right? Y hat equal to wx plus b. This is what for a single neuron we will have a like this, wx into b. W is 1, x is also 1, x is given here, right? Random numbers. Then b is given as this. So how will you find the different, loss? Loss is nothing but y hat minus 2. If it is a squared error loss, y hat minus y whole square. That's it. See here, you will get the loss. If you want, you can back propagate. Then you will find this is what the W grade and B grade. This is the gradient that have back propagated and you got this. This is how original, this is the true code that is behind in the gradient descent algorithms. Okay, this is how the gradients are being modified. Initially, the gradient is 1. Am I right? Since I have set this gradient 1, right? Initially, my value is 1 as per this code. See here, this code, tensor code. Initially, these are 1s, but after back propagation, see here, my gradient has been, the value W, del W. This is nothing but a del W. I have already often used to say that, right? Wt plus 1 equal to Wt minus eta into del W. This is what the del W. This is the thing multiplied with the learning rate and I am going to add with my weight. This is how the weight is going to be updated. Okay, already my weight is a tensor, so this is not at all a problem for me. So you can do this in the loop. See here, this is initially as usual, I have set the learning rate. Whole hard code is given for you. This is for exercise. Please make a note of it. There is no need to write everything from the scratch, but if in order to learn the things, you have to experiment with these things. Okay. So this is my W tensor and B tensor. I have printed these items. See here. If it is a tensor, you have to give 1 and 0. Then initially my W and B are 1. For I am taking 10 in the epochs of 10. I have random values of 20 cross 1. Then this is my true output, true function, y equal to 3x minus 2. This is my y hat. Okay, I am finding this, this is the y hat. I am defining this as a y hat. Then I am finding the difference between it. Okay, y hat minus y. Sum is given because this is a 20 cross 1 matrix, right? Whereas this is a 1 cross thing. So this is done here. I have given a back propagation. Okay, see here. Then see here, there is a thing called width torch dot no underscore grad. If you say this one, once you get the back propagation, this backward will give you the gradient, right? Yes, this backward will give you the gradient. Now you got w dot grad and b dot grad. You got these things, right? Now what will you do? W equal to w minus eta, this learning rate into w grad. B equal to b minus eta into b grad. The same formula is applied. You have done this. Okay. Now with no underscore grad means you can use this value, but see here, now this back propagation is stopped for a while. Have a look on it. Now this back propagation is stopped. Now you are updating the weight. Then what you have done, now you have made your gradient to 0. Okay, now this W also becomes 0. This is in place, right? This is in place 0. So all the gradient becomes 0. Again you will propagate, back propagate. Now, so that's why you are in this control of this block. So if you have given bit, so you have done a back propagation for a while. After back propagation, this will return the gradient. The gradients are present in W dot grad and B dot grad. So for a while, you have stopped the back propagation and started working on it. If you have not given this, against back propagation will be in progress. Now your W grade and B grade will be changing again and again. This calculation will not be fine. So now you have set this value, I mean you have reset this value, and again you will go for the computation. Now I have printed the what is the value of W and value of B, because since this is a tensor, right? So in order to find the scalar value, I have to go with item. So this I have done, this is I have done for 10 iteration. Yes. Are you getting the point out of it? So during my calculation, this back propagation has to be halted, and after that it has to resume with these updated values, Okay, for next iteration, it has to work with the updated values, right? That's why it has been done like this. So this is for large problem. We have given this. If you want, you can work on it. So these things are also tried with what is the time it is taken here. And I have given the epochs, learning rate, and number of items too. So if you look on this, it will take less time compared with this is torch. Okay, so I have back propagation and everything is there. In that I have used the device. See here, simple thing. Whenever you are using the torch, give additional thing as device equal to CUDA 0. That's it. Very simple thing. With this you are getting the minimal time. Okay. So with this, we have implemented a simple neural network. Simple, I can say that simple sigmoid neuron, I have done this. Okay. Back propagation is also there is a forward propagation as well as there's a back propagation. By default, this backward will give you the back propagation and it will return the gradient. You can access the gradient based on the values that are, see here, wherever you have given these things, you can access the gradient. Okay. Clear with this? So 5 minutes break here. We will resume the session by 3:05. Okay, if you have any doubt, kindly post me. Okay, we will start the session. So I want to know whether you have gone across the dataset basics in your course in this course session. How to load the dataset, like data frames, pandas. Is this concept done or not? Because this is essential. Train, test, split. Kindly anyone respond so that I will proceed with this aspect. Using sklearn Python library. Have you done with the sklearn? These things, how to divide the training data, testing data, if there is any deviations in training and testing error, these things are done. If anyone responds so that I can proceed. Yes or no? Is these things covered already or I have to go with that?
Go ahead, ma'am.
Is it covered already? Okay. So the next thing is that as of now, I am going with the clean data set. Kindly mute yourself on your side. Kindly mute yourself on your side. So as of now, so now we are going into the data set. So we have the predefined data set in scikit-learn Python library. So I'm going to import that data set and I'm going to work on it. As of now, the main outcome of this session, this 10 to 15 minutes is how to have a train and test it equally. We have to infer the data, then only have to give on it. Okay, so that this is very simple concept, but it has a major impact on the accuracy of the model. Okay, so the first thing, as usual, hope you have learned. Hope this is very basic thing I'm giving. This is not a new concept I'm going to give on it. This doesn't need any Pytorch or other things. Simple machine learning package I'm going on it. In that, because deep learning is always a built on cap of the machine learning. It is not that without machine learning you can go with the deep learning. It is a built-on cap on the machine learning. So scikit-learn is a machine learning library in Python. So in that, predefined data sets are present. Sorry, I forgot to share my screen. Hope my screen is visible for you as of now. So this is a simple sklearn library, Python library for machine learning. It has predefined dataset. It is well curated dataset. There is no noise and other missing values and all. It is a well curated dataset. You can go ahead and do that. In that, I am going to load the breast cancer dataset. So breast cancer equal to, in order to load that, you have to give sklearn dot datasets. You have this. I have not created any alias name. If you want, you can go ahead and do that. In order to load the dataset, you have to give load underscore breast underscore cancer. So this is a well defined. So there is no need to go on that. So in order to go with that, we will run this package. So as of now, I am running on the CPU. If you want GPU, you can go ahead. But if you enable the GPU, you have to accelerate in the code. This is very important. Simply going and setting these things in the GPU will not enable you thing. You have to reflect those things in the code. Then only you will get the reflection in the time durations. So I have loaded this. So X will contain the data. Data means you have the portions of features, all features. Target is nothing but your class. So this is a classification data set. You have a data plus class label that is called as target. We will print X and Y, then you will have a look, understand what is present here. See here, this is X and this is the Y. See here, Y. It is 0 or 1. Either it is present or not present, that is. So 0 and 1. So I have taken this. In this data set, I have to segregate the test and try. So shape is an attribute, right? Shape is an attribute. So you have done these things in the NumPy and other things, right? So that's why I have gone with the NumPy. See here, x dot shape is nothing but it will return you the, it consists of 569 rows of 30 features. Y dot shape, only that column, right? That's why. Even though it is a column, the column value will be empty, there it will give you the row. This is what one thing you have to understand on this. Next, I have imported the pandas because pandas will give you many functions compared to the, as of now, we are working on the raw data set. Raw data set, rows and columns. Now, we are going with data frame. In the data frame, this data frame will, what it will do is, it will convert these items into pandas objects so that it will be very useful for you. So data equal to pd.data frame of, I have taken only this data alone. My column is, I am going to give the column name from the risk answer dot features name. You can access the column names of the data set using this name, dataset name dot features underscore name. You will get these things. Okay. So next, data underscore class equal to breast cancer target. Here the target, I have already told that the target has 569. I want to know what are the classes that are present in the target. Okay. So in that you can get the things. See here. So these are the features. So data for the in data, this is a pandas object. In data, you have the column names and you can visualize these things, right? If you go ahead, in the last column, you will have a feature called a class. See here, this is a class. This will take the values of the target. That's it. Very simple. If you give the head, it will list only the top 5. Tail, last 5. If you want to give the describe, it will give you the all the statistical properties of this data set. Count, mean, standard deviation, minimum, 25 percentile, 70 percentile, and other things. Okay. So there comes next one. We have to know whether this database is biased or not. It means that I want to know whether all the data are towards a malignant or all the data are towards a benign, or it is well matured or well balanced. So in order to find that, you want to find based on class what is the value count. You can give this. So you will say that there are 357 and 212. You want to know what are those 357 and 212. So there are 357 items based on malignant and 212 items that are based on benign. Okay. So with this, I can say that more or less it is 60-40. I can say that. Am I right? So out of how many rows are present here? I think it is 569. Out of 570, half of the thing. 570 means half of the thing. So at 55 to 45, 55-45 ratios, the values are present. So my model will learn the things appropriately, because at least 50-50 are present. This will be a good. At least 55-45 is not at all a problem. This you have to ensure this. This is also one of the pre-processing you have to done. If the data is not balanced, whatever the thing you are given, always accuracy will be reduced. So, okay. So in order to do that only, there will be overfitting. Surely there will be overfitting. In order to go with that, you have to go for data augmentation. So these are some of the small tricks we have to take into account so that you will get the improved accuracy. Not only the model is responsible for that, some of the pre-processing itself, hyperparameter tuning is entirely different. If you take pre-processing itself, pre-processing and curating the data itself contribute more to the accuracy. Next, you have done this. Next, I have taken the mean of this. So just to know what is the mean of this class, for class 0, mean radius is 17. This is done whether the mean is more away from each other. See here, for class 0, the mean radius is 17, whereas for it is 12. Okay, if both are same, see here, if both are same, it is difficult for the model to identify. It should be divergent, right? So this should differ. Then only the model will know that since the mean is 17, I can say that this is goes to class 0. If the mean is very minimal, I have to go with the class 1. This is very important. There should be differentiation of it. If not, if both the values are more or less equal, it is difficult for the model to learn. Only the variations, based on variations only, the model is going to learn. If the things are nearer to each other, it is very difficult for the model to learn. That also has to be taken into account. It is not the individual value. At least mean value has to differ by some amount. We have to have a look on it. This is another pre-processing thing that will contribute for the accuracy. So the next comes the important thing. We have to split the training, split our data sets into training data and test data. So see here, I am talking based on the machine learning aspect. The same thing, see here, the same thing I am going to apply for the convolution neural network model. That's why I am explaining here. So it will be very useful if you balance your data, if your data set is balanced and if it is curated, your accuracy will be improved rather than that of the model. So from the scikit-learn library, from the model selection, I have imported a method called train test split. This will split your entire data set into training data and testing data. So based on that, you can get the things. So first, I will drop the feature called class along axis equal to 1 means along the column. So I have removed the class column because that is going to be my output, true output. Am I right? Then now my y, so I have removed this. The remaining features will belong to x, whereas y equal to data of class means this y will contain only the 0 and 1. That is nothing but the output, target class. See here, this is a data frame, right? This is a data frame. So always if you work with the data set, it will work like a data frame with respect to pandas. So next I have taken a train and test split. So train test split will return 4 tuple, 4 arguments in a form of tuple, x train x test, y train y test. I have given x and y. Okay, if you want, you can run this and you will find the shape of it. See here, for x, y dot shape. What is y dot shape? Y dot shape is 569. That y train is for training it has taken 426. For testing it has taken 143 samples. Okay, it is random samples. Okay, so this is it is up to it more or less. It is, I think it is 80-20. I think so. So in order to specify that this is the test size, this is a training sample. For instance, I want 90-10. 90% of the data go for the testing, whereas only 10% training, whereas only 10% go for the testing. In order to go that, you have to give an additional attribute called test underscore size equal to 0.1. In this case, this is nothing but I have taken 90% of my data for training. I have taken only 10% for testing. Yes, clear with this? So next one. So I have added more things on that. Hope you know what is the use of test size is one. Next, I have used stratify. See here. Stratify is nothing but, see here, you have a stratify equal distribution of features in the test and train. The thing you can notice this, how you can go for the stratify is that, see here, wait. See here, in the previous, okay, this is lengthy. See here, if you see here, before stratify, okay, before stratify, I have given y dot mean is equal to, I have given a train and training data of 90% with the test data of 10%. So y dot mean is nothing but, y here is nothing but output, right? That y dot mean, y underscore test. So this is whole. As a whole, this is the mean. entire wise mean is this. Out of this training is this testing is this. Okay, I can say that more things are concentrated toward training, whereas less things are concentrated toward testing. If both are equal only, my model will learn equally. So in order to go with that, you have to give a thing called stratify. Okay, now I have given printed these things with respect to y. Same thing you can test with the x data also. So since x has many features, see here, this is the mean parameters, right? Wait, I will run. So see here, for instance, the mean radius is 14.2 here. Okay, I will take this as a 1 in order to have a thing. This is 14.2. I think some of the things are hidden here, right? See here, this is 14.04, right? See here. So this is mean x train, then x test, then x mean. So this is train mean is 14.13. This is test mean, this is 14, more or less equal to. Okay, this is how you have to stratify the data in such a way that it is equally distributed. This is the use of stratify. Even though this is 90% and 10%, it has to randomly take the rows. It is nothing but records from the data set in such a way that the mean should be more or less equal. It is not that it should be accurate. 14.3 means everything has to be 14.3, at least in this range. Then only it will be useful for the model to train its features correctly. These are some of the pre-processing you have to done on it. So this is one thing. Next thing I want to make a note on here is that next one, random state. See here, if you doesn't provide the random state, so test, hope you know what is the use of test underscore size, what is the use of stratify, then random underscore state. Hope you know that random state is acting like a seed. So seed is used to reproduce the thing, whatever the thing. So each and every time it will randomly take the records. If you doesn't provide the seed, each and every time it will randomly take the record. For each execution, it will take random records for training. So in order to avoid that, you have to fix the seed. The seed is called a seed, can be fixed with the help of a command attribute called random underscore seed. Once you give that, the whatever the number of execution you have, for all the time, the same set of records are being used for test, train, and other thing. Okay, this is what the one thing in deep learning or machine learning, you have to reproduce the result. This is very important.
Ma'am, I have a doubt.
Yes, ma'am.
There are some random values given for random state, like 33, several values have been given. Is there any specific meaning?
No, ma'am. Whatever the value given, even if you give 1,000, not at all a problem.
So if we give random state, repeatedly the same set of values will be taken and the same accuracy will be getting.
Retained, yes, ma'am. That's it.
Okay. Thank you.
So in order to, so the important thing that whatever the article if you are reading, it is if they are provided the random state, if the seed is provided, you are able to reproduce the result. That is very important. So how many times? So since this is a runtime, right? For me, this is a runtime. After certain time, if I have closed and opened and I have run it, it will produce a different mean and radius. Surely it will produce a different mean and radius. You can see here, right? See here, you can notice these thing in this itself. See here, I will run this and show you. You will get the thing. See here now, initially it is 14.1086. Okay, now I am going to run it again. See here. See here, 14.1158. It should not be like this, right? So in order to overcome this issue, you have to go for this random state. This is what there are n attributes. I have given only certain things that will improve the accuracy. That's it. I have not covered everything. So have a look on it. This is how you have to split your training data and test data. Then it will be very useful for you. Okay. So I hope this is for these things. Hope you have got the things. I think so. Any doubts in this, you can ask me. So Please have a look on it. So tomorrow while you are working with CNN, so there is no explanation on these aspects. We will cover more on convolution and max pooling because I don't want to kill the time in these aspects. That's why in the basic itself, I have given you everything. Any doubts in that? If so, you can ask me. Very simple thing only. I have not given you any great things here. Very simple thing. That too already well curated data set. In that well curated data set also, the data is distributed in a wide range. See here. If you take the real-time data, it is very difficult. So it is not that if you have the data, you can apply the model, you get the accuracy. Not at all. Pre-processing is very important. Even though this is a well curated data, you have to pre-process in such a way, then effective use of function is very important. It is not that you have to train test split. You can use on that. It is not at all useful. So based on data, you have to give the attributes and you have to work on it. This is very important. One thing you have to remember. Any doubts?
Ma'am, this is regarding random state, ma'am.
Okay, ma'am. Okay, sir.
This random state, actually we need to fix some random state so that we will get same accuracy whenever we execute.
Okay, sir.
But what is is there any procedure to fix the random state? Because no, at particular random state, there is a possibility of getting very good accuracy.
No, so random is nothing but a seed. So it is not that the state is not maintained. Please have a look on it. It is not the internal state of the model or other thing. It is nothing but a seed. It will produce you the thing that is what already been done. It is like a model that is pre-trained model. Hope you have heard of a thing called transfer learning, right?
Okay.
There is a pre-trained model will be there. If the accuracy of that model is already very high, I can use that model and I can go with my data and other thing. So this random state number will give you an indication that for this environment, or I can say that for this data set, this is an, I can say that a pointer to that with which you have to split the data like this.
Okay.
That's it.
No, for another random state, I may get better accuracy, no?
No, it is not with random.
Okay.
Sir, please have a look on it. Random, with random number, there is no accuracy at all.
Okay, no, because with random, randomly assigning data to the model, at particular random assignment, we may have better set of data for training, no?
That can be done only with Stratify.
Okay.
Random state has no influence on it. That can be done only with the help of Stratify. Stratify is only going to have equal distribution. If you have equal distribution, then hopefully you will have a good accuracy, right?
Okay.
That's it. So Stratify is an important role. Whatever the question raised by you, the answer for this is Stratify, not a random state. Random state is nothing but a pointer to you saying that this is how your distribution has to be. That's it.
Okay. No, my question is, ma'am, say that I am fixing random state 10.
Okay.
I am getting accuracy of say 92.
I
am going for another random state, say 15, for which accuracy will be different.
Okay, sure. Yes.
At that point of time, at particular random state, I may get very good accuracy, no?
It is not because of random state, because of Stratify only you will get. You will check the thing, sir. I will share you the collab.
Okay.
Check this and tomorrow you can ask this question. One thing is that you have, without Stratify, set a random state and check for its distribution. Check at least mean and other things. You will have a thing.
Okay, ma'am.
Because of Stratify only, you will get the more or less correlated mean.
Okay, ma'am. Okay. Thank you, ma'am. Thank you.
So, is there any more doubts yet to be clarified?
Ma'am?
Yes, ma'am.
You have discussed about the already predefined data set. So, how we can specify the Stratify and random state for custom data?
Or wait, ma'am. Only 1 minute. I will post a link so that other people can work on it. Yes, ma'am. Can you repeat the question again? Sorry for asking this.
Ma'am, we have explained about the predefined data set, well-defined data set.
Yes.
So, how we can set the Stratify and random state for custom data?
For your own data set, are you asking like this?
Yeah.
Yes, same thing. Nothing is different. Only thing you have to change here, right? You can load, if it is a CSV, you have to give it as PD dot load underscore CSV instead of here. See here.
For imaging data, ma'am, image data set.
Same, ma'am. If you have image, go with this link. You have to give the URL of the link, am I right?
Yes.
Okay, just give it. If it is a PD dot load underscore CSV, if it is a CSV, go with CSV. If it is a URL, load underscore URL, give the URL. That's it. Then, as usual, same procedure. This is this data set is present in the sklearn dataset repository. That's why I'm taking on it. If you have your own data set, for instance, I'm saying that you have load your data set. Hope you know how to load the data set here. Am I right? For instance, you can upload this here. Just have a PD dot load underscore URL or load underscore CSV. If it is an image, load underscore dataset. That's it. Ma'am, are you getting the point?
Okay, ma'am. Thank you.
Ma'am, there is a function, ma'am. In Pandas, there is a function to load the data set. If your data set is CSV, you can, if it is present in the local, as far as the cloud environment, this is a local, like our local disk. If you want this, you can mount this with the Google Drive also. There is another thing going on. If you want, you can upload this. This will be present only for this runtime. When the session expires, this will be erased. So this, if you want to load that data set, what you have to give? Pandas PD dot load underscore that name. If it is a URL, load underscore URL. If it is a CSV, load underscore CSV. Or if it is an image file, you have many functions to load the data set into this Colab laboratory using Pandas. You have to use Pandas, ma'am.
Okay.
Then as usual, you can go with the Stratify and other thing. Actually, your image has to be transformed into binary, right? If you have your image, you cannot go with the image as such. It has to be encoded into numbers. You have to transform this. Once you have transformed, you will get the mean, average, and other thing. Based on that, you can stratify and you can specify the stratify and the test size.
Ma'am, how to deal with negative numbers if our data contains negative numbers?
So there is a normalization, ma'am.
Okay. You have to convert into certain range.
Yes, ma'am. Normalization. You have to go with the normalization, or you can say it as standardization.
What happens to the negative value? It will be converted into positive.
No, ma'am, it will not be converted into positive. Whether it will go with a mean value or based on that, you have heard of min-max scalar, min-max transformation. Have you heard of this?
Yes, ma'am.
Will be applied, ma'am. Based on that, if it is a min-max means go with the minimum and maximum value. If it go with the mean, you have a certain transformation. So there are n number of transformation there. Based on that, you can go ahead.
If my problem has some impact or some special meaning to that negative, that means if positive is there, the stock price is going upwards. If negative is there, it is going downwards. In such case,
ma'am, you want to retain your negative value as such is in your data. Am I right, ma'am? Yes, ma'am, you can go ahead with your data, but you can to give this transformation. There is a transform function in TensorFlow as well as in the Pytorch. This will say you whether you want to retain the original value or not during the standardization itself.
Okay.
If you want, you can go ahead with that.
The meaning will also be preserved.
No, the meaning will not be preserved. The value will be preserved. Actually, in transformation, in standardization or normalization, meaning will not be preserved, ma'am. Only the range will be reduced. For instance, if you have 1, 10, 200, 300.
Yeah, that is okay. But I need my, that means during some operations, this negative value will create a different impact in the operation.
Okay, ma'am. You can check. For instance, I'm saying that if you have a feature, one feature, that feature has both positive and negative, that can accept both positive and negative value. For instance, I'm saying So you want to retain those value during transform, you can say that you can retain those value, but manually you have to say that if its value is less than 0, this is a incident. You have to say on that value. There is no automatic direction of positive and negative value based on the application.
Okay, ma'am. Okay. Thank you.
But in semantic analysis, this is present with respect to RNN and LSTM. This is present with respect to NLP. This is present.
Okay, okay.
Okay. Hope the things are fine for you. I hope so. So next we will go into the feed-forward network. Don't worry about these things. Just I'm going to give a glimpse on it. We have written a scratch code for feed-forward network. That's it. So the simple thing is that we are going to create a layer on that. On that layer, we are going to build build the number of hidden layers and other things go based on that. So there is no need to write all these codes in the Pytorch or TensorFlow. Already everything is present. Please have a look on it. Only thing you have to give is the number of neurons, number of hidden layers and everything. So these things can be done in CNN or RNN only, because there only we are going to use the model. If it is an image, you have to go for convolution neural network. If you're going with a time series problem, you have to go for RNN, okay, like NLP and time series, like what I can say, stock price prediction and other aspect, you have to go for RNN. So the thing I have given here is that this is how internal thing, because we have seen every thing that are internally working, because we are concentrated only on the black box of the deep learning model. So this is how the internal model has been built. So based on that, you have to give the input. This is how the input will be processed and react to that, and you'll get the output. So that's it. So as of now, this code has no impact on your implementation. I will give you the thing right as a thing. First itself, I'm giving these codes will not have impact on your application specific implementation, just to know how the internal things are working. So tomorrow, while you're working with CNN and RNN, you will get a clear picture on how the internal things are working. So that then only you will get, if you come across any errors and logical things, you will easily clarify the things with respect to tensors. So simple thing. So as of now, I have set the seed for regeneration as usual. I have set the regeneration. So I have created a thing called first one, wait. I have imported n number of data. Don't look on these things. Okay. So now I'm going to create a simple data set. Okay. Have a simple data set. I'm creating my own data set. I'm going to generate a data. Instead of taking from any data set or another thing, I'm going to create a blob object. Okay. That is nothing but a blob in Matplotlib. Hope you have seen these objects, right? Image like dot, star, or hyphen, double hyphen, these things you have present. These are nothing but binary objects, right? Binary large objects you can make on it. So this is the thing that I am going to take. So this is a tuple, data comma labels equal to make underscore blobs. The number of samples here is that 1000. Cent is equal to 4. Number of features equal to 2, and random state equal to 0. This random state is meant for this data set. This random seed is for my entire execution. Please have a look on it. Okay, this starch.manual seed is for my entire execution, whereas this is different. So as of now, I'm going to use, this is matplotlib colors. I'm going to have a CMap. In that, I will show you why red, yellow, and green are present here. See here. So see here. So this is data and label. I have made a blob object. In that there are 1000 samples, center 4, n number of features equal to 2, random state. I will tell you what are those features. So there are 2 features I have told, right? There are 2 features. I mean 2 columns are there, and labels dot shape as usual there will be 1000. Okay, 1000 columns column based, one column with 1000 entries will be there. Next, I have given these data into a scatter plot. Okay, with the thing as label, with C is equal to label and C map equal to my map. My map is given as, this is a map entity. This is for our interpretation. From the linear segmented color map, I have taken red, yellow and green. So these are the colors I am going to give for that. Okay. So I have given red, yellow and green. If I have not given, I have told it is the center is equal to 4. I have given only 3 things. Remaining thing it will take on its own. So the next thing what I have told, as usual, X train, X val, Y train, Y val, train test split, data, labels, X and Y, stratify equal to labels. So stratify is based on Y, means based on Y. Y is nothing but based on labels. That means stratify equal to Y is nothing but based on target, you have to have a equal distribution. That's why in the previous data set, I have shown you stratify equal to Y means based on the attribute, I can say Y. I have to have a equal distribution. Y is nothing but a target class, that is labels, right? So I have equal distribution. If I have 4 classes here, if I have 1000 objects here, I can equally split into 250, 250, 250 each. Hope you got the things right. Yes. So X train equal dot shape, X value, then labels dot shape. So hope you got this right. So based on that, it has been stratified. Here for training, by default, if it can take 75-25, it depends. It depends. I have already told that I cannot say that you have to take 80-20 or 60-40. I cannot say that. It is a random value. It will take on its one. If you want to have the fixed value, you have to go with test underscore size equal to point something. That is percentage you have to give in decimal value. Okay. These things are a simple thing. As of now, I have not taken any data set because already defined data sets are already curated. That's why we have created our own data set and have made a thing. Next, I am going to use the torch on it. I have the test data. I have the training data. See here. Wait. Getting it away. Okay, data is not defined. Okay, now I am going to apply my autograd. So what will happen is that, so I'm going to have a training data and I have printed, I have 750 items out of that as my training data. See here. So now I'm going to define the model. Please have a look on it. I'm going to define a model on my own. Please, there is no need to write the model on your own, since I have to know whether these are the things that are internally present or not. This is how the deep learning models, what we are using. For instance, if it is a image, I may use VGG network, right? Or I can use Google Net, or I can go with the ResNet and other things. But we are using the ResNet, but we are not sure about how the internal working is. Same thing, how the feed-forward network will work, which is nothing but a fully connected network. If you go with the CNN, the last few layers will be fully connected network. This is how the internally this fully connected network will work. Okay. So I have done this. See here. Hope you know what is MATML. First, I have to for our sigmoid neuron, assume that this is a sigmoid neuron. For sigmoid neuron, our function is 1 by 1 plus e power minus wx plus b. Am I right? So in that, first I have to aggregate the thing. So in order to aggregate, what I will do, I will go with w into x. So that is what the w into x. Then this is the bias. Wx plus b, you got this. Then you have applied, this is the pre-activation, that is what A. Next, you are going for activation. In that, you are going to apply the sigmoid function. Mostly, sigmoid is used if you go with CNN, mostly tanh is used. If you go with RNN, ReLU is mostly used. Okay, they have proved that that is more efficient. Okay, from the literature, it is proven that TANH is more efficient for CNN and ReLU is more efficient for RNN based applications. Next, what I have to do, this is what my H1. Similarly, I have to assume that there are, the scenario here is that you have a 2 input, 2 neurons in the header layer and 4 neurons in the next output layer. This is what the scenario, try to imagine that 2 input neuron, 2 inputs, above the 2 inputs you have 2 hidden neurons, above that you have 4 neurons, okay, for the output. So what you will do, so for the first neuron you have, I have already told that there are 2 neurons in the hidden layer. So for the first neuron, this is A1, H1. For second neuron, this is A2 and H2. See here, for A2, so for this, assume that for this is second layer. Okay, so this is, if it is one A11, A12, then A21, A22. So second thing I am saying that here, I have done this here, right? So first one I have done WX plus B, then I have applied sigmoid, then this is activator, then again I have to WX plus B. Here W is nothing but H1. I have to take the things of H1 as the input, then weight, then bias, right? So hope you know these things. If the dimension is n comma 2 into 2 cross 2, you got the n cross 2. So this is n cross 2 again. Again, hope this matrix multiplication dimensions are clear for you. Next comes the plays an important role. See here, H2 equal to A2 dot exponential e power A2 by A2 dot exponential dot sum of -1 and unsqueeze of -1. So what this will return, I will run the thing, then you will get the things out of it. I have given you an example here so that you will get the things out of it. Okay, see here, if you this is e power A2. Okay, exponential you have given e power A2. Then this is first this will be executed like this, e power A2 dot sum of -1 dot unskews of -1. Unskews is meant for even, I will give you the things step by step. So while I calling the thing, I will show you the thing. So first what it will do, this is nothing but a softmax. I can say that this is a softmax. That is what the thing given in a single line. Instead of writing the softmax as a thing, this is the thing that is internally there. E power AZ by summation of AZ, right? Clear with this? So in that, what will get? I will get a single value. In that, for that, I have to go with 4. If there are 4 outputs, I have to flatten my vector in such a way that it has to go for 4 things. That is what the thing. Clear with this? So now I am going to return this H2. Next, I have gone with y hat. So y hat, this is what the tensor.torch, I have given you the predefined value. Then y equal to, I have given, this is y hat, this is y. Already it is predefined. This is for working, how this is working, only we are going to simulate on that. So here I am not going to emulate whatever the deep learning model already present. Now I am going to simulate the thing that are present internal to the deep layers. Okay, those hidden neurons, how these hidden neurons will be architecture. That's it. So first one, what I have to do, this y hat equal to torch.tensor. This is the value for this y hat. Okay, then this is the actual output. Hope you got these things right. So these are the, if you add these things as 1, hope you know that this is the softmax. I can say that this is the probability value. If there are 2 classes, this is a I think this is this hope. If you add all these probability, you are getting the 1. So in sigmoid neuron, always output the thing as probability basis. If you apply the softmax, you will, if there is any negative value, you can go with the softmax. So in order to avoid that only, you are going with the softmax. So this is an assumption. Please have a look on it. This is an assumption that this is what my y hat is. Okay, next, this is what my expected. So this is the true thing. Always y hat is the predicted, y is the true label. My true label is 2, 0. For instance, I am saying that this is 2, 0. We will see how this will works fine. Next, I have taken this at range of y hat dot shape of 0. So y hat, what is the shape of y hat? So y hat dot shape of 0 is this is right. So this is one row with 1, 2, 3, 4. Okay, this is one. Then log of this is nothing but, hope you got the things. I think this is nothing but a cross entropy. Are you getting the thing? So in order to write the cross entropy in your application, you can just call cross entropy alone. But internally, this is what the code for cross entropy. Okay, clear with this? So next one, argmax. For instance, I am saying that this is what the output for my multi-class application. For instance, I am saying that this is the maximum value and this is going to my class. So this is what argmax is going to do. Okay, so this is nothing but this is a code for cross entropy, and this is a code for, see here, the same code will be here. Item will give you the value itself. This is meant for cross entropy. This is meant for picking the data that have the maximum probability value. So whatever the probability value has, if the probability mass is high on a particular value, you are saying that that is going to be the output label. This is how the internally this is going to interrupt. So please have a look on it. These codes you are not going to write on it. This is how internally the tensor will work like this. So I can say that this is a 0.5. So the next one, this last function as usual, this is accuracy. Just have a look on it, that's it. Don't think that I am saying that just have a look on it. Whatever the things I have taught you in the morning session, that is being implemented in the coding aspect. But these codings you are not going to use in your application. When you come into the CNN, if you have any issue, if you know the internal details, you can easily solve the issues. That is what the thing required for. Okay, so this is what the accuracy. I have written the function for it. So next come the weights. I have initialized the weight. I have given you the gradient for that because I have to back propagate it. Same thing for bias 1. Similarly for weight 2. And also other things are given, learning rate and epochs. If you go with these epochs only, it will learn fine because this is a fully connected network. Then I have x train equal to, I have to convert these data into a float value because that is a blob object. I have to convert this into a float or a long value. So initially its accuracy is, list is empty. See here, y hat I have now called the model. My model is this. This is my model. See here, W. So this is my model. If I take the model, it will return the H2. After that, what I will do? After that, I will provide the last function. Based on the last function, I have to back propagate it. Then what I have given, I have appended this loss in the loss array. Then I have calculated the accuracy. I have called the accuracy function from the sklearn. Hope you got this right. I think this is, I have written the accuracy. Okay, I have written the accuracy. If you want, you can get it from the sklearn itself. It will work fine also. Then this is what for each and every epoch, this is how back propagation is done. Hope things are clear from this. Since I am going with requires underscore grade, sometimes you will get an error that requires underscore need and a scalar value, but you have provided a tensor. You will surely, I am saying that you will get a thing like that. In that case, you have to know that you have to convert the tensor into NumPy. That's it. Okay, if you got any errors like this, this is what the internal meaning. So next thing, I am going to update this weight and bias. Same thing. Then I have reset this weight and biases to 0. Same thing what we have seen in the sigmoid neuron. Okay, simple thing we have seen. Now I am applying it for a large feed-forward network, and I have plot these accuracies and other things. This is what my training loss before training and loss after training. Okay, so now after training, my loss is reduced to a maximum extent. Yes. So these things cover some more aspect on it. So if you are okay with this, is this fine for you? Are you getting the point out of it? Is things clear for you? I hope I have given you only the internal things. Make sure that these things you are not going to implement in your code, but if you get, surely you will get an error in all the aspect. So if you know these internal things only, you are going to have a thing on it. So for simple thing, I can show you a thing. If you are using the Pytorch, you can back propagate using backward function, and you can identify where the error is. Why the accuracy is not improving? Is my gradient got 0 at some point because of vanishing gradient? There is no algorithm to identify whether there is a vanishing gradient or not. It is where hyperparameter tuning only help you to find the vanishing gradient or not. But with this back propagation, with the help of this gradient, this auto gradient function of Pytorch, you will get the gradient right. Once you get the gradient, you can know that the accuracy is not improving because the gradient is 0 here. If the gradient is 0 for n number of epochs, then whatever the number of epochs you are running, it is not at all the thing. Even though you have improved given the learning rate as minimal learning rate or other thing, your accuracy will not improve for most of the cases. So you have to know the thing out of it. In order to find that, what you can do that, in addition to this, you can back propagate with the help of a backward function. Then try to print the gradient of it for each iteration. You can note that whether my gradient is going to decay or not. If it is going to decay, stop, go with the early stop. Okay, so these are some of the tricks you have to go with that. So in addition to programming your applications or implementing your application, these are some of the internal. Now you are going to touch your model. Now you are going to inquire your model, give the gradient at each state. I want to know whether you are able to go with the minimal loss or not. If you are not going with the minimal loss, I can know this is how my gradient is explosively increasing. So surely my weight is going to increase. If my weight increases more, I will not get the minimal loss and improved accuracy. So this is the inference you can get on the things and work on it. Okay, this is one thing I want to touch here. Don't worry about these codes and other things. These codes are not at all necessary for you. The thing is that the takeaway from here is that you have to know how the internal things are working. If you know that, you can push your model to work for your data, because I cannot expect the data to be very pure and very curated for my need, because real-time data is very nasty and noisy. It has to overcome many issues on that. In that case, model has to be curated like this. I'm going to inquire model again and again. What is your gradient? Give me the gradient. I'm going to I will tune my hyperparameters in such a way that you have to adapt to my data. Okay, I cannot change my data. The thing that can be changed is only weight and bias. For that weight and bias for each iteration, I can got with the help of the backward function. Then I'm going to see what is the loophole in that. I will find out and pick on it. So this is what the takeaway I'm expecting from this session. If this is fine, this is good. Okay. Any more doubts? Ma'am, is this session is up to 4 or 4:30?
It's up to 4.
Okay, ma'am. Okay.
We will conclude that session.
Okay, ma'am. Okay. So that's all from my side. So your feedbacks are at most welcome. So thank you for giving me this opportunity. Thank you.
Thank you, Tamil Chelvi, for giving a wonderful session. The feedback is posted in that chat box. All are requested to fill the feedback. Again, we will meet tomorrow by 10 a.m. with the topic of deep learning models for computer vision. Thank you, one and all.